So my name is Igor Sedukin. I'm an architect on Azure Stack team. But actually, I span Azure Stack and Azure, and my job is to make hybrid possible. In other words, the apps that span clouds. So I work a lot on Azure, making sure Azure is deliverable as Azure Stack instance. So what we'll talk today is how do you actually develop applications for the hybrid space. Thanks for coming for the session. I know you have a lot of choice, so this is full room, so that's great. How many people are using Azure today? Okay, quite a bit. How many people have heard of Azure Stack? Okay. And how many people have tried Azure Stack Preview? Okay. All right, that helps me just navigate a little bit of the content that we're going to cover. So what are we going to talk about today? What is hybrid? What do we mean by hybrid, and why do you care? Why it could be important in a space of application developer? And then talk about designing and operating hybrid apps. We'll do a demo. We'll try to make the session entertaining so that you can experience and see how you actually can jumpstart a development of a hybrid app very quickly. And then talk about challenges and solutions we have. So the challenges in the space of hybrid development and what solutions we have for you to solve those. So Azure. So Azure has 28 announced regions, and it's all over the world. However, it's interesting that not all those regions are in a single cloud. So we have Azure China. That's actually an independently operated cloud. Its instance is different than the instance we run in here or in Europe. There's also US government. There's government clouds. They're actually independent clouds. So in this set of regions, some of them are part of global public cloud, and some of them are independent instances of Azure Cloud. With Azure Stack, we're actually enabling service providers, hundreds of service providers, to actually instantiate their own versions, their own instances of Azure Cloud on their premises, right? So even more. And then enterprises can actually set up their own private versions of Azure clouds. And so that makes another thousands of these instances of the cloud. So now, if that's what you have to develop an application for, to live in that world, how do you do it? So that's kind of the purpose of the session, to just explain how do you actually live in the world of multiple instances of clouds. So across all of those instances of the cloud, the biggest benefit that you gain as an application developer is the single Azure ecosystem. So your application artifacts are the same. So you can use Windows or Linux. You can use any of the languages that you like in your development and still target any of these instances of the cloud. You can use containers. You can use platform as a service services like websites or Service Fabric and target all these instances of the clouds. You can have single set of operations or automations around your app. Things like your CI lab can be one, running it against multiple instances of the clouds. And so there you're gaining benefit of writing a single application template or single command line script or single Puppet or Chef configuration for your machine, and then that applies to any of these clouds. You also gain the benefit of using the same set of tools. Things like Visual Studio or Eclipse can be targeted against any of these instances of the cloud. And then experiences, things like Portal or the gallery of services that you can deploy on the cloud. It's the same. So it's one ecosystem targeting multiple clouds. Jeffrey Snover is our technical fellow. He coined this expression that a cloud is a model, not a place. So what we're saying here is that Azure ecosystem of tooling and operations and everything is that cloud model. And then you can have it in any place you like. be that a private space or be that in a hosted world or in the public cloud. Same cloud model. So underpinning that cloud model, what enables it is a single cloud architecture. So there's an Azure cloud architecture that we instantiate in all these instances of the clouds. So underlying the cloud, there's infrastructure. There's a cloud infrastructure, and then each instance of the cloud, there's their own instance of that cloud infrastructure running. And so there's compute, storage, and network there, infrastructure management. In case of Azure Stack, that's the part that is operated by the owner of the cloud. In case of Azure Public, that's obviously Microsoft is operating that cloud infrastructure for you. On top of the infrastructure, there is a set of services. So there's a set of foundational services. And foundational services, they include compute, storage, network resources, as well as things like Key Vault, where you store your secrets. Right? That's part of foundational services. If you want to deploy a VM with a certificate, then you need to place it somewhere. So that's a set of foundational services. They're available in all clouds. And then there's a set of additional services, and those are the kinds of app services, the websites, the kinds of service fabric and container service, and many other additional services that could be had on top of the infrastructure. Baseline infrastructural services. There's a lot of services that we provide, but third parties can actually develop their services and extend this infrastructure and have services participate in this system. And then all of it is wrapped by a set of core services that offer things like subscriptions, role-based access control for any of the resource of the underlying service, things like Gallery, where you can pick applications that include resources from these services. So Gallery is a common service. Metrics, things like what CPU usage you have, or what number of requests you have against your website. That's metric, and that's commonly managed in the layer above the services. And the usage, so reporting on the usage and utilization of a service, that's common to all services. Then wrapping it all is Azure Resource Manager. That's actually sort of a key to the kingdom, right? This is what makes our clouds consistent and compatible from the application development and management perspective. So this is effectively that unifying application or resource model that unifies all resources of underlying services into a single application, single template that you can manage, and so on. So that's the Azure Resource Manager. And then on top of it, we have end-user experiences that include portals, Visual Studio, Azure SDK. All of those sit on top of Azure Resource Manager and then are able to target any instance of the cloud, any instance of Azure Resource Manager in any of the clouds that we talked about. And so that effectively, that stack enables the guest workload resources, things like virtual machines, storage, tables, blobs, virtual networks, things like service fabric clusters, like all of that is what enabled in your application. This stack enables it, right? So as a developer, you really have two entry points here. So one is you could be developing an application that runs on top of Azure. So you're just using Azure application model and developing your app and putting it in Azure to run. And that's probably 99% of this, of the audience. And then you can also develop an extension. You can develop a service that can also participate, resource provider that can participate in this ecosystem and extend Azure or extend Azure Stack with an additional service that others can be consuming in a multi-tenant manner, right? So you have these two entry points. Sometimes there'll be one, so where you're developing a service, but you're also hosting it on Azure. A lot of our internal services are developed that way, where a team in Microsoft actually uses foundational services in Azure to develop their own service, and then plugs in their resource provider into the Azure Resource Manager. So that's the architecture. What is hybrid then? So hybrid is really clones of this architecture in multiple locations, right? Multiple instances of this architecture in variety of places. So public Azure cloud, national clouds like Azure China, government clouds, right, still operated as part of Azure, and then service providers or enterprises, so they can have clones of their architectures, of this architecture on their premises. It's important to say that each of these clouds can actually be multi-regional clouds. So even a service provider can have multiple regions in their instance of the cloud. That said, that cloud is still operated by that service provider, not Azure, right? And so it's your private one with multiple regions. And so then these architectures is what enables the common ecosystem that includes Azure SDK and things like templates and images. You can share images, virtual machine images. You can share virtual machine extensions like Puppet and Chef across all of these instances equivalently. For the Azure Stack, the smallest footprint you can get is a single box. This is effectively what we released as our technical preview 1. The box needs to be beefy enough. It's a 96 gigabyte, 12 core server. But you're getting effectively Azure in the box. All of that Azure networking, private networking, blob service, table service, like all queue, all that stuff, you're getting in that box. So that's the smallest footprint. And then in a later previews, we will enable multi-machine configurations that will start from 4-node, hyper-converged, and then grow up. So that's kind of the smallest footprint you can get the Azure on your premises. It is important to note that foundational services are available in all clouds. That's a must. So they're not an optional. Additional services, however, are selective. So a service provider installing Azure Stack can select their set of services to host, or can just be okay with just foundational services. We'll talk about later how you deal with that variety in the clouds. But that's important to understand and note. So we kind of arrived to this place where you may be in a position of developing an app to this multi-cloud instance world of Azure, right? Multiple clouds of Azure, multiple clouds of Azure Stack, right? Multiple different instances. And so that's really what we're going to talk about. How do you do that? But first, let's talk a little bit about why. Why would you actually care to develop to this multi-cloud world? So mobile. You could be developing a mobile application that's backed by a service you host in Azure, right? And while you're operating on countries that are okay just using public cloud, then that seems fine. You may want your mobile application to be used in places where Azure is at national cloud, like China. Well, in that case, your service actually needs to be ready to be deployed into Azure China Cloud. And so we'll talk about how you do it, but this is the motivating factor for being able to target multiple instances from the beginning of a development of an Azure application. So you may end up in this position. Industrial. So we got a lot of customer interactions and demand from a variety of disconnected places like oil rigs or factories that use IoT. And they want to use it locally. They want to operate the factory locally to the location because satellite link is very expensive and they don't want to connect to the cloud for every one of the operations locally. And so they want to run a local copy of Azure Stack. And so then while operations of the Azure of that factory in the Azure Stack are local, you may have some business analytics that gets offloaded to the cloud so that your people who run your company want to understand the production schedules and so on across these factories. And so that could be on a slower connection basis and so on. So then you may end up, you may find yourself developing an application for a customer like that, or maybe you are a customer like that that says, well, this is my environment. And so then your application needs to be ready to be deployable and working in an environment like that. Global enterprise, things like airlines or cruise liners, right? Cruise lines where you have a ship that just in the sea, and they may want to run an entertainment or check-in, check-out application in there. And so their application developers gain from ability to use that Azure ecosystem and all those tools to be able to target all these local deployments of their check-in, check-out, or an entertainment application in that ship. And then some part of their application would still run in the global cloud. That's where you may keep your accounting, but the actual entertainment happens locally on the ship, and so it doesn't need to be from the cloud, doesn't need to use a satellite link. So that's another case of for a hybrid application development. Another one is smart city or digital cities, sometimes they're called. This is where regulations or tax code in many of these locations require that the applications that are used by local community or funded by local community are actually staying local, right? And so not only data needs to be local, but also the service provider that runs that application needs to be local in that location, right? This is, sometimes they worry about, again, regulations. Sometimes it's just sovereignty of this location requires that. And so you may be developing something like a GIS application for that local city that allows local citizens to go and look for communications and layout of the land and stuff like that, where the actual GIS data is local and hosted locally by a local provider. But map data could be coming from the cloud, or some part of your app could still be running in the cloud, then some part needs to run local, just because this is the kind of app that needs to be developed. And so you may find yourself in this situation, and then you have to understand how to develop an app like that. Workload mobility and scale. This is another interesting case we hear constantly is it's much easier to gain 1,000 machines or 1,000 VMs temporarily in public cloud than it is in the private cloud. So you may have some sort of an event like benefit selection day that you want all your employees to go to your website and update something or other. And so your website, the intake of the employee data could be in the cloud, benefiting from a scale where you can scale it out for that day or that week, and then scale it down very quickly after that event. Whereas your backend could be local and then ingesting this information slowly through the queue, right? And so your backend could still be local, but your application could be, your website could be in the cloud. Another case we hear very often is an insurance policy. So a lot of enterprises want to start using Azure, and they like Azure, but they're afraid of, like, if you start there, then I get stuck. And then if for some reason the application my devs developed now have to be brought on-prem, because maybe we found some regulations that require that. So Azure Stack provides that insurance policy for the enterprise. And so when you develop an application, they may ask you, saying, well, I'm okay you using Azure, go develop app for me in Azure, but make sure it runs in Azure Stack, because just in case, I might need to bring it on-prem. So again, another case where you might find yourself in this situation. So for all these reasons, you may find developing an app to the hybrid using the Azure ecosystem. So let's do a little bit of a demo on developing these applications. So I'm going to connect. I'm going to connect to my demo box. And I'm going to start from showing in a hybrid app and then tell a story of how I developed it or what tools I used and so on. So I'm going to start in Azure. And so this is Azure Portal. And in this Azure Portal, I have this resource group called Build 2016 Demo 1. Click there, and This resource group contains part of my app, that web application. The web application I deployed into Azure. And so it has SQL, it has my website, it has my storage in here. So that all has been developed and put in Azure. For those who are new to Azure, the resource group is this concept that basically is used to put together a set of resources that are related together. They form an application. And then you can do things like assign role-based access control to this resource group to say who is going to be administrator of this app, who's going to be just the observer, who's a developer, and so on. You can use this resource group concept for many, many reasons in Azure. And then what's inside of resource group is resources. And resources are effectively these elements of your application that have things like metrics and billing associated to them and so on. So they're kind of manageable parts of your application, like a website. So in this case, I have SQL, I have web host, and then I have this website. So if I click on this website, it shows me sort of the management side of my website. It allows me to do things like enable Git publishing in it and so on, tells me how many requests have ran so far into this app and so on. So what we're going to do is just click on the app here, and then you'll get woken up. So I was talking for too long, and then this is a free tier. I'm using a free tier web application. It spins down my web app if it's not used very much. That's kind of part of managing our compute, and that's why it's free. So it has to now load. Great. So this is just the ASP.NET website, and all I did is have a text box I enter, and then I'm going to send this message to the queue and pick up on the back end. So I'll say, hello build, send it off to the queue. And so that's my website. So imagine this is my user interaction in the cloud. Maybe this is my benefits selection application. I'm going to move, switch over to a different portal here. This is Azure Stack portal. I'm actually connected to a private instance of Azure running in that single box machine. We'll go look at it in just a few seconds. But this is its portal. As you might notice, the URL is different. So URL is Azure Stack, local. This is the portal. And I'm effectively just VPN'd into that environment for the moment. But what do I get? I get the same Azure portal that you just seen. Like, it's hard to see a difference unless I show you that URL, that this is actually a different portal, a different location. It's the same portal in a different location. This is Azure Stack. And in here, I have the same set of Azure concepts, things like resource groups. So I'm going to go click in here, and here you see that Build 2016 Demo 1 resource group, which now contains the backend part of my application, right? The part that has VMs and a NIC, and it has the VHD storage account for that VM, just like it would be in Azure, except I decided to put this VM with the backend code in Azure Stack and deploy it there instead of Azure. So I'm going to click on the VM, and it's going to bring up the management aspect of the VM. It's going to show me a few things. So it shows me, IP addresses and so on. I'll show you a few things here. We have this concept of VM extensions. So this is a way you put your code or modify the guest configuration of the VM. In this case, I used PowerShell DSC. We're going to go look at how I did it. And I put in backend logic into that application, so into that VM. So my app get deployed into the VM and get configured in there. So what I'm going to do is connect. So like I said, just like I would connect to a VM in Azure, I'm connecting it to it here. I'm going to provide the password I gave when I created the VM and connect to the VM. And so there you go. So that's actually my backend application that I just deployed into the VM using that DSC script, using that application model of Azure, now running here on the on Azure Stack instance. And it picked up that message that I typed. You can see the time is appropriate. So what I'm going to do now is, for a few seconds, let's see, close this. By the way, it's build 2016 demo1.azurewebsites.net. So if you're so inclined, go ahead and type something at the end of the session. We're going to just take a look at it. I remember we had a long time ago this build keynote where people were developing application on stage and then it got hacked right away. So just go ahead and do it. It'll make for some entertainment. So that'll be my user voice tool as well. I'll hear what you got to say. Anyway, so next thing is I'm actually going to go and show you this Azure Stack machine. So this is that host, that single machine that runs Azure Stack. And so I have my portal VMs in here, my networking VMs, and all that Azure infrastructure squeezed into this set of VMs. Right? This is actual Azure code, literally Azure code taken from Azure running here. And then I have this VM that was created when I deployed. So how do I know that this GUID is that VM? Well, I got this notes, right? It says it's resource group build 2016. If you don't see it, I don't think I can make it bigger because it's a RDP session. And then it says VM backend. So we have this note that says this VM belongs to that tenant, and just so that you know on the backend infrastructure. So all I'm going to do is try to connect to this VM and show you a couple of things in there. Oh, there you go. a@b.com. Thank you. So, so you got some, some live. So you see now I found that VM, and it's actually on my private instance. Although it looked like a VM in Azure, I was able to do anything I can do with Azure here. And somehow it's running here locally. Let me show you something about it. You see this says Windows Azure Guest Agent. So it's actually important. So what we did is we made sure that our Azure Stack infrastructure serves the same guest contract to the VM. Things like configuration, things like heart beating, things like all that management of the guest in Azure Stack. So what you can do is you can literally take a VHD or an image, however you want it, from Azure and put it in Azure Stack, and it will run. It will experience the same kind of contracts that your application experiences in Azure. And so key to this is this guest agent as well as the part of infrastructure that serves these protocols to the guest. We're actually using what we call a metadata protocol that's on a local link. And it's publicly available, so we have things like instance metadata that you can read in your script inside of a VM to find out things like what is my subscription that this VM is deployed to, and then behave accordingly. So that's my local instance. So that kind of shows you an app a little bit, but let's talk more about how to develop an app like this. So that was an app, and you've seen how it's managed and so on. How did I achieve that result? Well, I started a Visual Studio solution, and the first thing I did, I said, okay, so add new project, and I chose Cloud, Azure Resource Group, and then when you choose, it gives you this selection of things to start with. So you can start with things like Docker containers in Linux, or you can start with Windows VMs, or you can start with web apps. And so what I did is I added two of them. One was a website project, and one was a VM project, right? And that's how I started my hybrid development. So I'm going to cancel it out. So for the front end, I have this template. So when the project creates a set of content, to deploy to Azure. In this case, this was a website with SQL. So you can see here, right here, you got resources, SQL Server, website, and so on. So we have this visual representation of this template. This is an Azure Resource Manager application template that describes multiple resources, SQL, storage, website hosting, and so on. So far, just regular Azure development, right? And so what I did is I deployed this right here from Visual Studio to Azure. And then I developed my ASP.NET website, and I said, publish right here, and then it discovered the publishing profile, and I published it to Azure, right? So very quickly, I got my Azure part going. What about Azure Stack? So I've added this backend.vm project, and in it, there is this template. And this template, just like the other template, describes a set of resources. In this case, I have network adapters, storage for my blob, VM, and a set of extensions that I deployed, virtual machine extensions that I decided to deploy to the VM. So this is what this template describes. And then, before I show you the DSC, I want to show this. So once I created this template, this application project for my backend VM, I deployed it to Azure Stack. And look how easy this was. Same way as I did it for Azure, I'm just going to show you here for Azure Stack, is I'm using my Microsoft identity to log in to Azure AAD, right? That then discovers the presence of my subscriptions in Azure and Azure Stack at the same time. So that single identity automatically discovers that I'm connected to the Azure Stack instance, right? That has ability to deploy this application. Just because I'm using that one identity and my Azure Stack is actually also using identities from Azure AAD. That's the way it was set up. So you're benefiting from single identity, a one dev developing a single app right here. I got a hybrid application project that I can now work with, right? From very quickly, from the get-go, you got the hybrid application project. And so I could have, so in case of website, I chose my Azure subscription here, and then in case of VM, I chose my build demo Azure subscription inside of the Azure Stack instance. All of it has been enabled through Azure Active Directory as well as Azure Resource Manager running inside of my Azure Stack. It actually told Visual Studio that I'm here, and I got these endpoints, and you can use them, and here are the subscriptions that this identity can use. So all of it was metadata from the Azure Resource Manager. So what happened here is I chose resource group. It says what template. You can add the parameters to the template. And then this is an interesting one. This is the artifact staging account. So you choose the artifact staging to upload your bits that will then get deployed to the VM. And Visual Studio does it automatically. How does it do it? Well, first what I did is I added backend logic, and backend logic is just a console application that I developed, so it's very simple, outputs, exe, nothing fancy. I've added the backend logic as a dependency to make sure it builds before my cloud application project. And then I've added this extension. How did I do that? So if you right-click on resources in this resource view of the template, you can say add more resources to the template. And here you get a lot of choices of things you can add. You can add network interfaces. You can add OMS agent into your Ubuntu, a variety of things you can add. And then what I did is I chose this PowerShell DSC extension, right? And it asks me for what VM name I want to input it, and then the name of the extension. So that's how I added it. It was very easy. Once I do that, Visual Studio actually automatically generates a set of parameters, artifact location, and a SAS token. So it'll actually automatically wrap up the build results of this project. and put them up in the storage account that I choose so that my DAC script, for example, can use that location to download the backend logic or other artifacts. And so here you can see the DAC extension what it does is it says what DAC module to use, what SAS token that will be generated at deployment time by Visual Studio to use, and then what parameters, so node name, backend logic zip. This is something that's going to be actually zipped up and put inside of that staging location for me, and then a SAS token. So I'm just passing these parameters to my DAC extension, right? Then in my project, I get this DAC script. That was also added when I added the extension. So let's take a look at that script very quickly. So all I got here is I'm taking the parameters I declared in my template in here. And what I'm doing is I'm writing a DAC script that will download the backend logic and then install the backend logic. Again, this is just an example, so I'm not trying to be very elaborate here. But you can do very elaborate things with DAC. This here I just deployed. And so what it does here is at the download time, it simply does invoke web request with that SAS token. And so when I go and deploy my application like this, and I choose that staging account, Visual Studio will automatically take my build outputs, put it in that storage account, right? And then when actually my DAC extension runs in that VM, it'll pick up those binaries and deploy. So kind of rounded up deployment and development of that artifact happened right here in the Visual Studio, right, against Azure Stack. I could have deployed the same VM in Azure. That's another benefit. So you can even start developing applications in Azure, and then when you get a private instance of Azure Stack, in that deployment dialog, you're going to get an option to deploy this and try it out in Azure Stack automatically, right, if you have access to that instance. So that was a bit of application development artifact. The other thing you can gain here is there's a Cloud Explorer, and a Cloud Explorer also shows you Azure and Azure Stack resources if you have obviously access to them. And in case of things like web apps, you can do things like attach debuggers, and so it's quite enabled development. And so right here, from the get-go, I quickly started with a hybrid application project. So this application actually deploys to 2 places, right? It was very quick. It wasn't even several hours. I got the hybrid application going. Well, great. So that's application development. What about operations? So I have this little project here with a bunch of scripts. So imagine I'm developing this. This is in a Git repository, and I'm running some sort of continuous integration lab. And what it does, it pulls from that Git and deploys my app, runs the test, and does it regularly, and so on, right? I can have the scripts right here in my Visual Studio solution, and then have them pulled out of that repository. So first, I'm going to show you command line. So if you are using something like Jenkins, you may be using Linux, or if you're using Mac, you can use this as a command line. This is a regular command line experience. So what's happening here, I'm running this demo. What it does is it actually logs into Azure, and then it's going to list me VMs that I have in my Azure subscription. And then it's going to go and log into Azure Stack in the same script and list me the VMs that I have in Azure Stack. What's the point of this? First of all, this is a hybrid script. So it's one script that I can write that operates against 2 environments. Now, how did I actually do this? We'll talk about it a bit later, but the reason why I didn't have to type in any of the credentials when this ran against 2 clouds is because I'm using a thing called service principal. So you can create a service principal, and you can have a certificate, and then you can basically use that same service principal against multiple environments, right? So what's important here is identity is one, targets are different, right? And so right here, I got the script that allows me to do things like operate or deploy my application from a single script somewhere in the continuous integration lab, and it acts against multiple environments. So that's the CLI, and obviously the same experience you can get on Mac or Linux. It's exactly the same set of commands you can run. Let me quickly show you the PowerShell demo. So we obviously have multiple command line clients, and we love PowerShell, and so here it is. I'll show you a few things in here. First, I'm going to run it. So PowerShell is a bit more expressive. So what I did is effectively I did an equivalent of get resources in a resource group command, but a hybrid. So what this script does very quickly is it gets me resources from my build 2016 demo 1 resource group in Azure, combines them with resources locally, and then shows you. So what can I do? Now I can do things like I can do my A and B deployment. I can manage that hybrid application as one set of resources. Just like that, right? Very simple script got you into the hybrid ability to operate and develop and deploy your app. Here's a trick. Might be interesting. So I'm using this feature of our PowerShell system called profiles. What you can do is you can basically have a session, you can manually log in, use your service principal, and create a session with Azure or Azure Stack, and then you can save it into a profile, into a file. Then what you can do is you can actually take these profiles and deploy them with your continuous integration workers or build workers, right, in a secure manner. So these profiles could be part of the environment where script is simply loading and leveraging them, right? Very easy way to, again, to save your credentials and automate things this way, right? And yeah, and so as you can see here, the script is very simple. It just loads one profile, gets the resources, and combines it with the other. So very easy to develop and get started with these applications. Where do I source inspiration for this? Or where do I find the apps? So there's Azure GitHub. There's a lot of templates in Azure GitHub that you can start with, right, for Azure. We actually have Azure Stack GitHub as well. What it is basically a snapshot of Azure with a set of subsetting, because not all applications can deploy right now to Azure Stack. So this is a subset. So I got, things here. You can do things like you can deploy Linux, with Docker. You can do things with Azure Stack that are pretty capable, but you may not get CloudML and other things in there yet. And so this is a starting point, good starting point, so you can just sort of look at what is even deployable, what I can use in the hybrid development, what will deploy in both places is basically this GitHub. All right, so basically that concludes the demo. So this demo was about developer productivity with hybrid applications. That's sort of what I want you to take away, is that you can start very quickly and you can be very productive. Let's go back to our presentation. And let's talk about challenges and solutions we got in this space for you. So endpoints. All these clouds are different instances of a cloud. They are actually not accessible through a single endpoint on purpose. So the Azure China has a different URL on purpose. Azure Stack will be having a different URL on purpose, because it's independent. And you want it to be that way. You want it to be targeted independently. And US government has another set of endpoints. And so basically that's an important aspect to understand and incorporate in your app development when you're developing Azure apps, that it's not just azure.com, right? Or the login on ADFS URL is different. So we have ways of dealing with it. Our command lines are pre-built with understanding of multi-cloud targeting. And so if you do things like Azure account environment list, you will actually see a set of profiles, a set of endpoints built in there. However, if you're building an application and you want to be dynamic, we actually serve this set of endpoints on anonymous call to Azure Resource Manager. So you can hit an API endpoint, and then you can discover other endpoints that you should be using. Things like, for example, which authentication endpoints to use for my OAuth against this cloud, right? So don't hard code endpoints. So we see a lot of templates out there where people are hard coding endpoints. We actually have a good language constructs that allow you to not to do that. You can actually develop good templates that are very adaptable to the environment. And you gain from this not just that it's Azure Stack, but also you can deploy to things like Azure China if you did this. If you hard coded your endpoint, that template doesn't go anywhere else but that place, right? So don't do that. Identity. So we have basically 3 ways that the identity works with these systems. So first is Azure Active Directory, and this is the same one that your customer would use if you're Office 365 user, right? Onboarded with Office 365. I had some statistics. I think it's like 5 million organizations are actually onboarded with AAD. So you can gain quite a bit of ability to interact with people by just connecting your system to AAD. So Azure is obviously authenticates against AAD. You can also set up Azure Stack while all private installation, all VMs are local, but identities that you use for the portal connection, for the ARM, for the script interactions and everything could be coming from your Azure AAD tenant or organization, right? This is one way, and this is probably the easiest to start with because it gains you all of those things I just showed you in the demo. Single identity, Visual Studio, operating against 2 clouds, very easy, right, from the get-go. Second, you can actually set up Azure Stack with a private AD and ADFS connection, right? This is where it's completely disconnected. It's not even talking to cloud at all. It's completely private. Nobody can see it. It's yours. It's important to know that in this case, you're basically enterprise and you're unlikely to be a hoster because that IAD is a single tenant from our perspective. You can still have multiple subscriptions, but from identity perspective, they only come from that AAD, of that Active Directory, not from any other place. Whereas in mode number 1, you can actually have customers coming from a different company to your portal and signing consent form and saying, okay, I'm just going to use your instance of Azure Stack very easily. Third mode is if you're going to China, that's a different instance of AAD. You're not going to authenticate against login windows.net, just different URL. And so Azure Stack can also be set up with a connection to China AAD, right? So all of these modes, just be aware, it's very important that these are the modes that the systems operate. So for developer, again, the main point here is don't use your personal identities for your scripting or anything like that. Use service principals. Service principals have been created to represent effectively an automated identity acting, right? You can still use the same facilities. You can assign roles and access rules in the portal against your resources. You can still authenticate everything you do as a person you can do using this principle. However, it's an automated principle. So how do you do it? You create a cert. You create a service principal in AAD with that cert authentication, and then you assign a service principal to a role on your subscription or resource. And then you use that cert to authenticate a principal and obtain a token from AAD. That's going to be a temporary token. And then you can use this token in your HTTP requests, right? Either directly in the authorization header, or you can use our client libraries that automatically wire it in the right place. So this is the kind of code you can write. There is that URL points you to a documentation piece that describes how to do it precisely. I just want you to take away that use service principles when you do this work against multiple clouds, right? Otherwise, you have to type in your credentials. Your personal accounts will never work like in an automated manner. You will always be forced to authenticate. Service principle is a different kind of account. Versions. So all of these clouds will actually be on a different cadence. So Azure may have v3, whereas Azure China still doesn't have it. And then Azure Stack is still on v1 because it's been deployed by some service provider and he may not have updated it yet, right? So it's very important to understand that clouds have different cadence. They have things in them that will not match the latest. So what do you do? So basically the first thing is the Azure Resource Manager tells you what versions are there. So if you're developing a dynamic application, we actually tell you what versions are in this cloud. As a scripter, you can access this and act on things like, tell me what providers, what services are enabled in this cloud in that script. And you can develop dynamic scripts that say, well, if I don't have website, then I shouldn't be deploying it here, and so on. So basically, we give you this information so you can build this dynamically adjustable automations. The other thing is versions we largely handle inside of our scripting layer. So when you target a particular cloud, we will actually find out what versions we should be using, and so we make it easy for you if you're trying to use command line, if you're trying to use PowerShell, to interact with a multi-version cloud. But again, if you decided to go and program against APIs directly, then we actually give you all the information you need. What do we use these versions for? What's the point of using the versions? When you develop an application and you type in that API version up there, we actually use JSON schema inside of Visual Studio or tools like Eclipse to validate your resource. So you not only get IntelliSense, but you also get things like validation, whether or not that particular property is part of that version, right? And so we make it easy for you to develop. The other important point is that $schema up at the top of every template. It's actually important. It tells Visual Studio where to go get the JSON schemas for all the resources. What happens is we update it automatically. So when a new version comes out, we actually put out a JSON schema out there, right, that is referenced by that schema. And so if you're sitting in Visual Studio, just because we got new version of some resource, you can immediately start using it in your Visual Studio. It dynamically pulls this information. It's not built into Visual Studio. It dynamically pulls information about versions and tells you what you can use when you're developing against these Azure templates. Capabilities, so things like VM sizes. Not all clouds will be capable of hosting the same hardware, right? Certain sizes are available in Azure, may not be available in Azure China, and applies to Azure Stack. The person who's deploying Azure Stack may choose hardware that is not of G kind, right? The G sizes in Azure, very large. So again, we have not only APIs, but command lines that allow you to interact with this. So for example, when you query VM sizes in West US, it gets you a very long list of VM sizes available in Azure. If you do it against Azure China, it'll be a smaller list. If you're doing it against something like Azure Stack with this local region here, it gives you very few, because I actually deployed this Azure Stack on a very low-end hardware, so it cannot do very high-end sizes. So when you're developing your scripts that automate your deployment, you can actually use this to adapt your deployment and say, okay, well, in this cloud, I shouldn't be using that particular size. I shouldn't even try. The second thing is, don't build Azure templates that embed VM size information, hard code them in a template. Make sure it's parameterized. So the way to do it is you can have a parameter and then you can have default value. So default value is what you recommend, but this is what you can support. So your application can support multiple sizes of the VM, not just one, and so you can parameterize it this way. That makes it very easy to deploy your application into multiple clouds that may not have all those sizes enabled. Another important point is images. Not all clouds will have the same images, virtual machine images. Some vendors may not choose to put them in certain national clouds, and Azure Stack hosters or enterprises may choose not to have all of the possible images that we have in Azure. So again, we have a way that you can discover this information and automate against deployment, right? So you can use command line, and it built in a way where you can query for publishers. So publishers like Microsoft is a publisher, and you can query for SKUs. And so what SKU is things like Windows Server, right, or SQL Server. And then from the SKU, you can query a set of images. And so those images would be things like Windows Server 2008, Windows Server 2012. Like that's what images are, and that's how you can actually automate if you're writing a script. This will work against any cloud. This command line itself will work against any cloud. And it allows you to be dynamic. Another thing in templates. So in templates, again, don't hard code images if you can. I mean, sometimes you have to. If you have to use a particular version of SQL Server, then there's no choice. But where you can, where you are not dependent on a particular version of an image, go ahead and parameterize it, provide allowed values in your template, and then you can bind that choice that the user makes to the value. We're working on making it much easier for the user to actually, when he deploys a gallery item, to choose that. So you'll benefit from us working on making these choices easier for the consumers of the template. But if you didn't do that parameterization, then we can't help much in our gallery UI or otherwise. So other solutions, so this is sort of a development. And then in the operational space, we have a set of things you can do. You can use ExpressRoute. So ExpressRoute is low latency communication to your backend. So if you have that backend logic that you want to connect to your Azure application, ExpressRoute is a very efficient way to have communication go. So you can have VMs in Azure literally join your local AD if you want to, right? So ExpressRoute. So management. We have Operations Management Suite. And so effectively, when you develop these hybrid apps, you can leverage Operations Management Suite by putting their agent as an extension in the VMs. And it allows you to manage across multiple clouds. So the point of Operations Management Suite is that it is actually cross-cloud. In fact, it can manage your VMs in Amazon, or you can manage your applications in Amazon, in AWS. And so Operations Management Suite is the hybrid management for your backend, for your applications. Application Insights is another capability. It's built into Visual Studio largely. When I develop website, it's just right there for me, and it allows me to monitor my apps and see their exceptions and behaviors and performance and other things. And again, that will work across any of the instances because it's it's a hub and spoke model where have agents pulling information to Azure Service, and then in the Azure Service, you can see a single view of your hybrid application and its behavior. We have other operational solutions to help you operate your app or run it. We have Store Simple, which is a storage solution that allows you to offload to Azure for your storage needs, and then disaster recovery like backup and site recovery. So these are the tools you can use in the backend if you developed your hybrid application like we talked about. So we talked about application design and development patterns, and then sort of operations for this hybrid. This is what I want you to take away is how easy it is to start with hybrid. And we're doing everything possible to make your life easier, even more easy, to interact with these multiple cloud instances. This is our strategy, is to have multiple cloud instances, and we're going to do everything possible to help you, and we'd love your feedback, hearing like what else you need and how else you're finding it useful or where we can improve. So takeaways, Azure and Azure Stack is hybrid. Apps should take advantage of hybrid and should be designed. So from the get-go, you should think about designing for Azure. If you're writing an Azure application, you should think of that application as, from the get-go, hybrid. We're fully committed to making you successful. And then calls to action. So you can learn Azure API. If you learn Azure API, it works on Azure Stack. That's how it works. You can try out Azure Stack Preview on your own hardware, obviously. There's requirements up in that URL. And you can try out the apps. So you can go to that GitHub repository and see if any of those apps are relevant to your space and try them out against the Azure Stack and Azure instances. There's Azure Clinic. If you want to learn more, you can go to that space on the third floor where we talk more about Azure or Azure Stack and just experience it more. We have a booth for Azure Stack. You can go in and play around, just see what the instance looks like more than what I did in the demo. And then thank you for being here. And then provide us feedback. We'd love to hear what you got to say. Now what I'm going to do is I'm actually quickly going to go back to that machine and see what happened. What we got? There's my machine. A little clumsy here. Oh, we got some stuff going on here. Anyway, thank you for attending. This has been enjoyable. So I'm gonna go look at it, and I hope you were moderate. And I'm gonna.